For this last lesson, we're going to look at the applications for solving systems of equations. So, for the first example, two numbers are related. The sum of the first number and the square of the second number is 18. The difference between the square of the second number and twice the first number is 12. Which system models this relationship? Well, first, if I look at the first sentence, the sum of the first number and the square of the second number is 18. Well, it looks like in all these cases the first number is x and the second number is y. So I would say that the sum of the first number and the square of the second number is 18. Well, that eliminates this one and this one right away. The second part, the difference between the square of the second number, and difference means subtraction in math, and twice the first number is equal to 12. And in this case, well, this one doesn't work because it's the square of the first number. And this one actually doesn't work because you're subtracting the y squared from the 2x as opposed to the other way around, remembering that the order does make a difference when we're doing subtraction, which means that none of these work. For the second example, two whole numbers such that the first number is increased by triple the second number, and that's going to give me 24. Well, I'm going to call my first number x and my second number y. So I'm going to say x plus 3y is equal to 24. If the first number is squared, x squared, decreased by 5 times itself, minus 5x, the result is means equals in math, 13 less than the second number, which would be the second number minus 13. Just be careful of the order once again. Find the two numbers. Well, here's my two equations. So, what I'm going to do first is I'm going to say that I'm going to do this by decomposition. In order to do that, firstly, I need to have the y's on the same side of the equation. So I'm going to say that this is going to be x squared minus 5x minus y is equal to negative 13, or x plus 3y is equal to 24. Second thing is, I can't eliminate the x's because I'm going to wind up having an x squared still left, so I have to eliminate y. So in order to make these match, what I'm going to do is I'm going to triple the first equation so that the y's actually match up. And I'm going to say that now what I have is 3x squared minus 15x minus 3y is going to be equal to negative 39, or the second equation I can leave by the way it was, x plus 3y is equal to 24. Now, because the y's have the same coefficient but opposite signs, in order to eliminate, I have to actually add the equations together to get them to cancel out. So I'm going to wind up with 3x squared minus 14x, the y's will cancel out, and negative 39 plus 24 is going to leave me with negative 15. Or 3x squared minus 14x plus 15 is equal to 0. Here's the quadratic I'm solving, so I'm going to solve for x. And in this case it's factorable, so I'm going to say that I could take 3x squared minus 14x plus 15 is equal to 0. When I split it up, I'm going to have 3x squared minus 9x minus 5x plus 15 is equal to 0. 3x and x minus 3, and negative 5 and x minus 3 are equal to 0, which means that x minus 3 and 3x minus 5 are going to be my two factors. Now, if I know that these are my two factors, then I'm going to solve for the x's. So I can say that for one possibility, x minus 3 is equal to 0, so x would equal 3. For the other possibility, 3x minus 5 is equal to 0, 3x would equal 5, or x would equal 5 over 3. Now the catch here is when I read closely for the information, it said determine two whole numbers. If they're whole numbers, then this solution isn't going to work. Only the 3 is actually a whole number. So then I can put that back in and say, well, if the 3 is the only one that works here, then 3 plus 3y would equal 24. 3y would equal, when I subtract 3 from both sides, 21, and when I divide by 3y is equal to 7. So I have the coordinates where they cross at 3 and 7, and when I state the solution, the two numbers are 3 and 7. For example 3, determine the values of m and n if 3 and 4 is a solution to the system. Well, I know that that represents x and y. So if this is true, then I'm just going to start by subbing in x and y. I'm going to say that for the first equation, this would be the same as m times 3 squared minus n times 4 is equal to 32. In the second equation, m times 3 squared minus 5 times 4 is equal to n. And I can simplify both these. I can say that 9m minus 4n is equal to 32, or 9m minus 20 is equal to n. If I know that 9m minus 20 is equal to n in the second equation, I can just substitute that into the first equation. I can say for equation 1, 9m minus 4 times 9m minus 20 should give me 32. 9m minus 36m plus 80 is equal to 32. Which means that when I combine these, 27m, and when I subtract 80 from both sides, that's going to equal negative 48. So m is going to equal negative 48 over 27, and the top and bottom can get divided by 3 to get 16 over 9. If that's true, I can put this back into equation 2 and say that if I have 9 times 16 over 9 minus 20, then 16 minus 20 is equal to n, or negative 4 is equal to n. And in this case, m is 16 over 9, and n is negative 4.